All right, good morning. Happy Friday. I'm excited for this today. I'm gonna post pictures of my setup here because you saw what I was doing on Wednesday, but this is one of my favorite lessons to do during the year. It's not the same not being here with you, but hopefully you'll still enjoy it. So like you saw on Wednesday, what I got here is I've got a red light, a blue light, and a green light here, and we're going to do some color mixing and see what happens. Okay, so 20-25 minutes for the whole lesson today. Today there's a very teeny tiny thing that's just going to be helpful if you jot something down. So it'll be helpful to have a sheet of paper, and I'll tell you when you need to write it down. There's just one thing that'll be helpful to have. Okay, so what are we going to do today? Three things. We are going to talk about how the eye works, specifically not how the eye totally works, but how it sees color. And then we're going to talk about two types of color mixing. One that's called additive color mixing, and the other that's called subtractive color mixing. Yeah, and then that's the plan for today. There'll obviously be a check for understanding, and that's it. All right. So what this is a picture of a microscopic picture of what's in the retina of your eye. You've probably heard before that the nerves in your eye that see things are called rods and cones. The purple long ones that you see, those are the rods. That's why they're called rods. And then the short squat ones that are kind of hidden among the rods, those are the cones. Rods are really good for seeing brightness and darkness. I'm not going to spend a lot of time on those. What I'm going to spend time on is the cones, because the cones is how we see color. And this is the interface between physics and biology, because how the eye is built is actually more of a biology question, but it interplays with what we've been talking about with the wavelengths of light and why things appear the colors they are. Okay, so in your eye, this is my schematic drawing, my very dumb picture of an eye. But basically, in the back of your eye, there are these things called rods and these things called cones. I've drawn them as lines and triangles. But you only have, remember, if we look at the electromagnetic spectrum, you can have any color of the rainbow. However, you only have three types of rods in your eyes. Sorry, three types of cones in your eyes. You have one cone for seeing red, one type of cone for seeing red, one type of cone for seeing blue, one type of cone for seeing green. Okay, so if red light enters your eye, it activates the red cones. That's how you know the thing is red, right? If green light enters your eye, it activates the green cones. That's how you see a thing as green. But what if there's another color that's not red or green or blue? For example, what if yellow light enters your eye? How do you see yellow light? Well, to explain this, I'm going to go to my next slide here, and this is kind of, I showed on Monday, there was a picture of the electromagnetic spectrum. What I've done, or what I found in this one, is this is zooming into the visible part of the electromagnetic spectrum that stretches from red all the way to violet. Look at where yellow is. Yellow is right between red and green. So what happens when yellow light enters your eye is that it turns on both the red and the green cones in your eye, and that's how your eye sees yellow. Now, what's cool about that? What's cool about that is that you don't actually need every color of light in order to be able to trick your eye into seeing every color of light. Let me back up for a second. If you're watching a television, for example, your television doesn't need to be able to make all kinds of light. It just needs to be able to make red light, green light, and blue light. If it can make those three lights, it can make any color of light. Okay, I'm going to show you with my setup here. So I'm going to zoom in, and what I'm going to do is I'm going to turn off the lights here, and I'm going to turn on a red light, except that light is not the red light. I'm going to turn on the red light, and you see you got red, and I'm going to turn on the green light as well. And I promise you, I'm looking in my computer screen. I don't know if it looks yellow to you, but I promise you that it looks yellow to me. I don't know how my camera's doing. But if I shine red and green light together, I'm going to get yellow, okay? Again, there's no actual yellow light there, but the eye looks, but it looks yellow because it's turning on my red and green cones, which is the same thing that happens when when yellow light enters my eye. So this looks yellow to me, right? I'm going to try something else. I could do the green and the blue. So let me show that. So that's just plain green, right? That's all of them. That's just plain blue. Let's do green and blue. Green and, that was blue, sorry, and green. You get this, the technical name for this color is cyan. The perfect mixture of blue and green is called cyan. And then we've got, I'll do some blue and red, and you're going to get a magenta. I'm going to turn the red down a little bit because it's a little bit overpowering. But red and blue, perfect mixture is magenta. Now, how do you make your eye see white light? Well, remember, white is a mixture of all the colors, but your eye doesn't actually have to see all the colors. It just needs to see the 3 colors it can detect. So if I turn all 3, red, green, and blue lights on, I should see something that looks an awful lot like white light. But it's actually a little bit more fun than this, because what I can do, since I've got 3 different light sources turned on here, I can make fun shadows like this. So if I hold my hand up against the wall, you can see several different colors of shadows, right? We've got, first of all, where all 3 lights hit it over here, right? You've got white, because again, white is all the colors. You've got this little part here, I don't know if you can see, this part is just red, right? Why is it red? Because at that particular point, my hand is blocking the blue and the green lights. And so the only thing that's hitting it is red, right? Then I also have areas like, let me try and find one here. So I don't know if you can see, I think you can see in yours, right about there, there's a little bit of yellow. Why is there yellow? Remember, yellow is a mixture between green and red. So yellow is there because I'm only blocking the blue. The green and red I'm still seeing, but I'm only blocking the blue, okay? All right, I'm going to turn this off for a second so that I can show you, go back to my slides. Where is my mouse? So if I go back to my slides here, right, I'm going to show you the color mixing wheel. Again, you see if you've got red, green, and blue, when red and blue mix, you get magenta, red and green, yellow, green and blue, you get cyan, and when all of them mix, you get white. You'll notice the background is black. Why? Because what is black? Black is the absence of color, okay? So black is the absence of color, and then when I put all 3 colors together, I get white. Now, here's where people usually stop me in class because they say, well, this makes no sense to me, because if I start with a blank sheet of paper, I start with white. And then the more colors that I like, if I paint and I mix paints, I don't get more white as I mix paints. I generally get closer and closer to black, right? Okay, so there's something we got to talk about here. This, I'm calling it the color mixing wheel, but really we should call it the additive color mixing wheel. What's happening with these lights are adding light every time I turn another one on. So if I add all the lights together, I get white, okay? You'll also hear this, so this is the additive color wheel. You'll also hear this referred to, and some of you who have taken some art classes may have, particularly photography classes, you may have come across this. But this is also called RGB color mixing because it uses red, green, and blue lights to mix, okay? Now, this is a different thing than is happening if you're painting or something like that. The first thing I want to do, and this is the thing that I'd like you to copy into your notes. I just want to write down what we found. This is the exact same slide as what I have here, but it's just written in a different way. I'd like you to write these things down, and go ahead and pause if you need to, but it'll be helpful in the next slide to be able to refer to this. Red plus blue is magenta, green plus blue is cyan, red plus green is yellow, and then all of them make white, okay? When you're painting, you're not doing additive color mixing. You're doing something called subtractive color mixing, right? I don't want to give you that slide yet because I want to show you some fun things with subtractive color mixing. So the subtractive primaries are the opposite of the additive primaries. So instead of using red, blue, and green, we're going to use, I got a cyan. I don't know if you can see it. It looks kind of blue to you, but this is supposed to be cyan. This is yellow, and this is magenta, right? Now I want to show you a couple things. Let's say that I take a magenta filter. Remember, what kinds of light can get through a magenta filter? Red and blue. I'm also going to take a yellow filter. What types of light make up yellow? Red and green. So I get red and green can go through this. Red and blue can go through this, right? What's the only thing left if I put them together? What's the only thing that can get through if I combine this one only lets through red and green. This one only lets through red and blue. What's the only one that can get through both? Red, right? So when I combine these together, you get red, okay? Let's try a different one. So yellow, remember, is red and green. Cyan is blue and green. So what's the only color that can get through both of these? Green. I combine them together. I don't know if you can see that. Maybe I need to shine a white light on this. Let me maybe take my phone out here. Maybe you can easily see that that's green if I shine light through that. I don't know if you can see that or not. By the way, you get green when you do this, right? So then let's try cyan and magenta are the two I haven't done yet, right? Magenta is red and blue. Cyan is blue and green. What's the only color that can get through both of those? Blue. Okay. This is subtractive color mixing. This is actually what you learned how to do in kindergarten, but your teachers lied to you because your teachers said that the primaries were red, green, and yellow. They're wrong. They were right about one of them. One of them is yellow, but the other two are really technically cyan and magenta, right? Those are the three subtractive primary colors. So they look a lot like red, blue, and yellow, but they're not quite. If you take true magenta and true cyan paint and mix them, you will get true blue paint. So I'm going to go back to what we would call the subtractive color wheel. And again, it's called the subtractive color wheel because when you mix paints, you are not adding light. You are taking light away, okay? So what have I done here, right? Cyan again, cyan is letting through blue and green. So if I have a cyan filter, I have subtracted out red, right? Yellow is letting through blue and red. So if I'm doing yellow, I'm subtracting out, yellow is red and green, so I'm subtracting out blue, right? So if I mix cyan and yellow, cyan is subtracting out the red, yellow is subtracting out the blue, what's left? Green, right? If you've done anything with printing or you've done anything with photography, you've probably come into CMYK color mixing. What does that stand for? It stands for cyan, magenta, yellow, and the K stands for black. Okay, so what do I need you to know? There's a lot here. If we were in class, we would kind of spend a little bit more time on this. But what do I really need you to know? There's only really a couple things. When you add all the colors together, you don't get black. You get white. Why? Because you add all the light. When you do subtractive color mixing and you subtract out all the colors, you get black. That's why when you put your paints together, you get something resembling, that at least is much closer to resembling black than white. Okay, so additive color mixing, which occurs when I add lights, like I was doing here, the result of adding all the lights is white. The result of mixing paints, of subtracting all the colors, is black. Okay, those are the key things. All right, I'm gonna post. I got several really fun videos, or at least one that I can think of. There's a couple others that I'm thinking of, but I will at least post one. If you're interested in this and want to know more, I'll post some other videos. But that's all I got for today. I hope you enjoyed it. Today is the last day of new content for the semester. We will do some review on Monday. We will do a quizzy type thing on Wednesday. And then Friday we'll go back and give you time to do any makeup work you need, maybe any corrections that you still have to do, and that's it. I hope you guys have a great weekend. I'll be talking to you next week, but thank you for listening.